And I hope you're having an amazing day. So today we're going to talk about data binding into Einstein, right? And then after that, I'm going to talk about regularization concept in machine learning. So if you haven't attended my previous machine learning lectures, right, I would highly encourage you to go and attend that before you attend today's one because you won't understand what I'm trying to say when I talk about regularization if you have no idea about overfitting or underfitting models kind of stuff, right? But if you don't want to attend, that's fine. By all means, stay till Einstein. I'm going to talk about Einstein data binding today. It's very interesting. So we're going to use the same data set which we have created in our previous episode using recipes, right? So if you haven't watched my previous episode, I would highly encourage you to please check that out first before you attend this one, right? Cool, sounds good. The first thing first, you need to log into your org, and I've demonstrated in my first lecture, Introduction to Einstein Analytics and Machine Learning, how to register for an Einstein org, right? So please go and check it out if you don't know how to do that. That's cool. All right, so let's jump in. The first thing first, we're gonna go to our tic-tac-toe icon. We'll take you to Analytical Studio. So what we're gonna do, we're gonna create a dashboard today, right? And then we're gonna add 3 components, and then we're gonna talk about the concept of data bindings from there, right? Okay. The first thing first, you got to see this create button here, right? I think I mentioned to you, you got 4 stuff here. You can create an app, you can create a dashboard, you can create a story, you can create a data set. So today we're gonna deal with the dashboard. So we're gonna go here, and so now we have 2 options. You can use a blank dashboard, you can create a dashboard from a template. So we are not going to do a dashboard from a template because we wanted to keep our demo nice and simple, right? So let's go to blank dashboard here. And now, as you can see, it's a nice, pretty looking canvas here. Properties on the right hand side, widgets on the left hand side. So if you remember, I talked about it and briefly in one of the episode where we talked about filters and other stuff, right? And global filters. So I won't be going much deeper into that today because our main topic is to explain the data binding. Cool. All right. So let's drop a chart component here. Select it and drop it here, and we're gonna select a data set. This is our new data set. This is the one, as I mentioned, I've created in my previous episode using recipes, right? So if you don't know how to work with recipes, please check it out, my previous video. And so we're gonna keep it nice and simple. We're gonna do total amount, right? Nothing fancy here, right? Simple. And then we're gonna add a filter here on the top. And so the filter will be again linked to the same data set, and then we're gonna do be a name, right? And so nice and easy, right? Okay, let's save this one, and we're gonna call it as new dashboard binding. Okay, and just gonna make it as a shared app. I mean, you can do private, it's fine. So let's run this and see the behavior. So we have a filter here, nice and easy. So the filter works fine, right? Cool. All right, now what we're gonna do, we're gonna add another chart which looks in the form of a donut. You can add any chart you want, but you know, donut looks nice. I'm a fan of donuts if you like eating donuts. The chocolate one is my favorite though, but you know, the vanilla works as well sometimes. Sorry, I digress. I started to get hungry when I talk about donuts. Okay, so we're gonna do total amount again, and then we go to this chart icon here, and we will go to donuts here. Apparently, talking about the donuts, I heard in New Zealand, in Auckland, someone was selling a donut of bacon flavor. I'm not sure if you're from New Zealand, have tried that. If you have, please put the comment below. I will be keen to know because I don't live in Auckland, so I live in a small town in North Island. So, okay, sorry, and if I digress, my apologies. Okay, so we created the donut-looking chart here, right? So we're gonna deal with only 2 for now, just to keep it simple, right? So let's save it, and I'm gonna talk about the concept of binding now. So if I run it, right? So let's say I will select this. See, the chart changes, right? And let's say I select this one, You see, everything is getting reflected. Now you might wonder why this is happening, right? The reason why this is happening, we are using this component, three components here, the filters and two charts, and they're all linked to the same data set, right? So when they're all linked to the same data set, all the components, right, they bind together. That's how the concept of the data binding works here. What I meant by that, so we have a data set, recipe data set, right? And I'm using this chart, right? And this chart and this filter, all of them are linked to a field or to the data set, to that specific data set, right? So we are not using any other data set. We are just using one data set. So when that happens, all the components, right, associated with the data set, they get bind together, right? And then act together. So that's, but this can be changed. So I'm going to tell you how to change that. So let's go back. So let's say I do not want, when you change something here, right, I don't want this chart to be changed, right? So what I mean by that is that, let's say I want, when I click on 96, right, I don't want anything to happen to this donut chart, right? So let me show you what I meant by that. So let's say when I check 96, right, it becomes 3. I don't want this to happen, become 3. I want it to stay the same, right? I want this chart, my donuts to remain untouched. So how to do that? So go to this one. There is something, a concept called facets. So wait a second. Faceting, right? So faceting, so you can include, exclude. So for now, if you include, exclude, you can do based on query, just to keep it simple. So if I say none, right, and save it, watch the behavior closely. Watch it very closely. So we have now changed this one. Voila, nothing happened, right? So what happened is that it's telling the other chart, look, I don't want to be touched. I don't want to be changed. So it made sure that it's not going to change. Let's say what happens when you change it. See, even the filters, it has no impact, right? So the filters is having no impact whatsoever, right? Now, there's one important property which I wanted to share with you along with faceting, right? So faceting is fine, but what happens, okay, so we did this, nothing happened, right? So when we do this, the chart here gets changed, right? But when we do this, nothing changes here, right? That's because we still have a property called broadcasting enabled for these components, right? It can, this component can broadcast the information to all of the chart, right? It's fine. It's not receiving any stuff, right? I don't want it to receive information. That's fine, but I can still broadcast, right? That's the difference between faceting and broadcasting. So you restricted yourself from receiving information based on the input from other chart, but you are still broadcasting, right? So let me explain to you what I meant by that. So let's go to this property again, right? And go to query. And so you see this option called broadcast selection as facets, right? So we just turn this off and save it. Okay, and now what we're gonna do, we're gonna run this and see what happens. See, nothing happens. See, none of the data get changed. Now what happens is, now we change, only this one getting changed. Now so it won't receive any information, nor it can do any broadcasting. So we have stopped that, right? So this is one of the cool features you need to keep into consideration when you are building a dashboard, right? It might be handy. Sometimes client says, look, I don't want these charts to be impacted. I want the data to be consistent, right? I don't want people to fiddle with this, my donuts or whatever, right? So you can use this feature. So just keep into consideration, right, when you are designing the dashboard. Very, very nice and very simple feature at the same time. Okay, now, so similarly, you can use this for this way, right? So what happens, so let's say I don't want to broadcast the information from this one, right? And so here also the broadcasting is disabled. So now what happens is none of them can broadcast anything. So So whatever changes each of the chart performs, it will stay local, right? So let's say I do this, nothing happens. I do this, nothing happens. I do this, nothing happens, right? It stays local, right? So I do this, nothing happens. So yeah, cool. Right, now let's see what happens if I drop another filter here, right? And then I link this filter to a different data set, this one. And I link this to account beer name. And what we're going to do, let's turn the options back, right? Let's say the faceting all. And I want the broadcasting to be enabled. And let's do the same for here as well. And I want the, sorry, not this one. I want the broadcasting to be enabled as well. Save it, right? And save it. Okay, let's see if it works, first of all. Okay, so we have, okay, so pay attention to the left one. All right, it changed. Okay, and now pay attention to the right one. Boom, nothing happens, right? Yeah, of course, won't happen anything because now you're using a different data set, right? And which got no connection to this component, right? Now, you might wonder, oh, that's a problem. Can we do something about it? Absolutely, we can fix it. The way to fix it, I'll show you. So, click on this boy here and go to this, three dot, and go to connect data source. This is where the magic happens, right? New connection. Name is that test connection. Okay, test on. You can choose. Now what I'm going to do, I'm going to select both the dataset and link the dataset together using a common source, right? So filter is account name, right? And in this case, the filter is account name, right? And save it. Close. Save. Please don't forget to save your work, right? And then you say, oopsie, I forgot to save the work. Now, please save it, right? Okay, now, what do you think should happen? Okay, let's find out. Voila, right? Now the behavior is changing, right? How cool is that? Okay, let's go back to the other one. Hey, that's fantastic, right? See, now the behavior is changing. So this is exactly how you can link different, two data sets together to tie the components together using multiple data sets. So this is all I wanted to cover today as an introductory course for data set binding. We're going to look into more detail in our coming course. So I hope you find this session valuable, and please go and try it out yourself because the best way to learn is by trying it out yourself, right? It's my humble request to register an org and try it out yourself, please. Cool. All right, now we're gonna jump into machine learning, right? I hope you guys are excited. So we're gonna talk about regularization here. So regularization. I'm just writing in American English. All right, regularization. So why do we need regularization, right? In our previous episode, we talked about the concept of data set, validating data set, test data set, and training data set. Okay, now look at this curve. Okay, and we are having this curve. This is a loss, and this is a feature set, right? So this is your training data set, right? And this is your validation data set. Now, this is how. This is what happened when you train your model first using a trained model, right? You can see that the loss value decreases, right, as you keep on training, but the loss value for validation went up. You might wonder, what the heck did that happen, right? Well, did someone steal my bacon last night? All right, I was kidding. So what does this happen, right? I mean, how does this? So the loss has increased, right? Now we have a problem of overfitting here. So what does that mean is that you train your model with the data and you said, oh, it works fine. I'm keep on pumping the training data. I keep on pumping the training data. I have a labeled data set. Everything works fine. So I don't have an overfitting problem. I don't have an underfitting problem. And now when you train with the validation, boom, you start having an overfitting problem, right? So how do you do that? Solve it. So we're going to use the concept of regularization, right? So until now, we talked about minimizing the loss, right? So now we're gonna penalize the model to reduce the complexity. So what we're gonna do, so this is a mathematical stuff, right? So we have to, first of all, we are working with only minimizing the loss. This was our main intention before, right? Now this will change with regularization to minimizing the loss plus minimizing the complexity of the model, right? So we're gonna deal with these two things. So now, how do you deal with the complexity of the two model? So we're gonna do the L2 regularization concept, right? So what does that happens, right? So this one, right? This will become sum of squared of weights. That means W1 squared plus W2 squared plus W3 squared plus so on W. So as the value of the weight is, starting with 0, right? 0, it goes on. So when the value of weight is 0, it will have very minimal effect on your complexity of the model, right? As it goes up, the complexity of the model has an impact. So now this is also called as a ridge regression, right? This regularization, ridge regularization. So now there is so what we're gonna do, so we got this one, right? So now we're gonna multiply this with a regularization rate, which is called lambda. My apologies if you don't know what lambda, it's a Greek alphabet. We can use alpha, theta, gamma, whatever. We're gonna stick to lambda, right? So we're gonna do, so what happens? So this is a very simple concept, right? I'm not gonna go very deep into it. So this is exactly what we're gonna talk about. So very simple, right? So minimize loss, right? Plus, right? Lambda times complexity, okay? Now, the greater the value of lambda, right? What happens is that you will have a problem. When the greater the value of lambda, obviously your model will become very simple, but you have a problem of underfitting, right? The smaller the value of lambda, then you may have the problem of overfitting. So you have to work out the right combination, right? So you need to work out the regularization rate, right? So that's something you need to work out mathematically. So this is all the concept. There is something called L1 regularization as well. So we're gonna deal with L2. That's all we're gonna talk about today. So this is, so as I said, right? So we are, in this case, we are not trusting our training data, right? We have an option, right, which says in the beginning to stop the training data when the loss is more, but that can be a bit complicated stuff. But many people use that feature, but in this case, we stick to this L2 one. So as usual, what I said, that our main focus is not only minimizing the loss, but we're gonna penalize the complexity of the model as well. So that's how we did using this expression, right? And now we have introduced the concept of regularization rate. So this one determines, whether the model can be underfit or overfit. So the greater the value of lambda, so there are high chance, there's a likelihood that your model will be underfit. And because of less data, and then if the value of lambda is big, then it's more likely that your model will be overfit. So you need to find out just the right combination, right, just to work it out. So that's pretty much what I wanted to cover today. Nice and simple, right? So yeah, see guys, what I'm gonna do, right? The reason why I don't want to get into too much of code side is, right, because this is a basic Einstein code, right? I don't want it to confuse you. I wanted to give you guys this added bonus, right? So that once you finish this Einstein basic, you can go, you can go somewhere and say, aha, you know what? I can do Einstein. At the same time, I know a little bit about machine learning. I can understand what you're talking about. I can understand what you mean by when you talk about training set. I know what you mean by supervised training, supervised learning. I know what you mean by unsupervised learning. I know what you mean by label data set, right? I know what does feature engineering mean. At least you will have that vocabulary, right, to talk with the data scientist. If the data scientist, come and talk to you, say, look, do you know how the feature engineering does? At least now you know. Oh yeah, I know. There's a concept called one-hot encoding, which we talked about, right? It's a great way to keep the communication going, even if you're a functional consultant. Right? You don't have to overwhelm when you're dealing with data scientists, right? That's one of the main courses. I haven't seen this course anywhere who teaches the machine learning with Einstein, so that's one of the reasons why I started this so that I can help everyone out there, right? So that's all I wanted to cover today, guys. Thank you so much for attending. I really appreciate your time. So adios and greetings from New Zealand. Bye-bye.